When I ask my students who was Sir Isaac Newton, the very first answer that I get is Newton was a great scientist who invented the law of gravitation when an apple fell upon his head. Now I am not going into the controversy whether the apple really did fall on his head or not, since I was not born at that time. Neither it is verified anywhere by Newton himself. But I can definitely tell you, Sir Newton was way much ahead of his time. There are lots of theories and inventions and laws which were given by this great scientist, and those are as important in the world of physics as the law of gravitation. Hello students, my name is Onik, and today I am going to discuss with you one such very important law given by this great scientist, which perhaps laid the foundation for the mechanics that you are studying today. Make sure you watch the video till the end, and at the end of the video I am going to share with you one interesting fact about the topic. So let's begin. When I was in high school, and if by chance any stranger happened to ask me a question from physics, 50% of the time the question would be, state the laws of Newton. I bet this situation was not only faced by me, but generations after that, and the trend continues. Somewhere deep down we have a deep connection and love with these Newton's laws. When a student reaches class 9, this is perhaps the first important law studied by him. So what are Newton's laws? Newton's laws are a set of 3 laws compiled by Sir Isaac Newton, which changed the way people thought about motion before him. Today we are going to discuss about Newton's first law of motion. First, let us see what Newton actually said in this law. Well, Isaac Newton was born on 4th January 1643 in England, and he died on 31st March 1727 at the age of 84. In the year of 1687, 5th July, he published a book written in Latin named Philosophia Naturalis Principia Mathematica, which stands for Mathematical Principles of Natural Philosophy. This book describes the laws of motion written by him, and this law laid the foundation for the classical mechanics that we are studying today. For his first law, his actual lines in Latin were
Corpus omne perseverare in status quiescendi vel movendi uniformitare in directum, nisi quatenus a viribus impressis cogitura statum illum mutare.
Which translates to English to, an object at rest will remain in rest unless acted upon by an external and unbalanced force. An object in motion will remain in motion unless acted upon by an external and unbalanced force. Well, the credit for Newton's first law does not entirely go to Newton. It refers back to 2 other scientists, Galileo Galilei and René Descartes. Surprised? Well, let's go back to history. Aristotle, the Greek philosopher, had a vision that an object which is at rest is in its own natural state, but for an object which is moving, a continuous force is always necessary to keep the object moving. That means, once we stop the force, the object also shall stop moving instantly. But you all know that that is not correct, isn't it? If it were so, a cycle would stop immediately when we stop paddling. But that does not happen. The cycle moves a certain distance even when we stop paddling. Well, before 1600, people believed the theory of Aristotle. Galileo Galilei for the first time said that when an object is at rest, a force is of course necessary to start the motion of the body, but the force is not necessary to keep the body moving or to maintain its velocity. That means, according to him, when a body is moving, the force is no longer necessary to keep the body in motion. In the absence of the force, the body shall continue to move in the same direction and in the same velocity. Now this was actually the law of inertia given by Galileo Galilei. So before understanding Newton's first law, you have to understand the law of inertia. Okay, now let us first see what is law of inertia. Now inertia is the property of an object or a body by which it tends to remain in its state of rest or in its state of motion. Now based on this, there are 2 types of inertia. The first one is inertia of rest, and the second one is inertia of motion. Now what is inertia of rest? Now inertia of rest states that it is the property of an object by which a body which is at rest tends to remain in its state of rest. That means a body which is in a state of rest remains in its state of rest. Now let us understand this with the help of a few examples. The most common example. Suppose for example you are standing on a bus or a train which is at rest. Now when you are standing on the bus, your whole body is in a state of rest. The bus is also in a state of rest. Now have you seen this? If the bus suddenly starts, then the passengers who are standing on the bus or the train, they tend to lean backwards, or that means they tend to fall backwards. Now why does this happen? First of all, when you are standing on the bus or train which is at rest, your whole body is in a state of rest, but your body's lower portion is in direct contact with the floor of the bus. Suppose for example, this is the floor of the bus and you are standing over here. Okay. Now your body's lower portion is in direct contact with the floor of the bus. So I have divided this into two portions, your body's upper portion and your body's lower portion. Fine. Now when the bus suddenly starts, so this platform over here, this one suddenly starts, so the floor of the bus, it starts to move suddenly. Now what happens at this point? Your body's lower portion, since it is in direct contact with the floor of the bus, your body's lower portion also tends to move with the floor of the bus. But your body's upper portion, what happens to your body's upper portion? Your body's upper portion tends to remain in a state of rest. Why? Due to this property, inertia of rest. Okay. Now what will happen? Now this two happens simultaneously. That means your body's lower portion tends to go to motion and your body's upper portion tends to remain in a state of rest. Now if this two happens simultaneously, what will happen, you see? You will tend to fall backwards because your body's lower portion is starting to go in a motion with the floor of the bus, but your body's upper portion is trying to remain in its state of rest due to the property of inertia of rest. Okay. One more example. Have you seen some people shake the branches of a tree to pluck or to get the fruits from the tree? Now once you shake the branches of a tree, the fruits that are there on the branches, sometimes fruits fall down. Now why does this happen? Let us see with the help of this law of inertia, or you can say inertia of rest. Now when the fruit is in the branch, the fruit as well as the branch, they are in a state of rest. Now when you suddenly start shaking the branch, what happens? The branch goes into a state of motion, but the fruit tries to remain in its state of rest. Why? Due to this property, inertia of rest. Now these two happens simultaneously. The branch goes to a state of motion and the fruit tries to remain in a state of rest. So what will happen? One part, suppose the branch goes to a motion and the fruit tends to remain in a state of rest due to the inertia of rest. So they two will get separated. And once they get separated, the fruit is going to fall down. Let us see with the help of another example. Suppose you have taken a glass, and on top of that glass you have placed a card. On top of the card you have placed a coin. Now what is going to happen if you flick the card horizontally? Now once you flick the card horizontally, what is going to happen, you see? You are applying a force on the card, so the card will go away. But the coin that is on top of the card, that coin, due to the property of inertia of rest, that coin will try to remain in its state of rest. So what is going to happen? The card is not there and the coin is there. Now the coin was on top of the card, so the coin will fall down on the glass tumbler. So this is inertia of rest. Now you have to understand one thing. This property of inertia, it is the inherent property of any object. What does it mean? Inherent property means this property of inertia is present in every object or in every body of the universe, no matter what the object is or whatever the mass of the object is. Now let's go to the second part, inertia of motion. Now what is inertia of motion? The inertia of motion is the property of an object or a body by which the body continues to be in its state of motion. That means the body tries to be in its state of motion. Not only this, the body continues to be moving in the same direction and in the same velocity. So according to inertia of motion, a body which is in a state of motion tries to remain or remains in its state of motion. Okay? Let us understand this also with the help of a few examples. One of the examples I gave earlier, what is that? Suppose for example you are riding a bicycle. Okay. Now when we ride a bicycle, we apply a force on the pedals. So we apply a force on the pedals and the cycle moves forward. Have you ever seen this one? Once when you are riding the cycle by applying a force on the pedals, and suddenly if you stop applying force on the pedal, what is going to happen? The cycle should have stopped immediately, but the cycle does not stop immediately. Once you stop applying force on the pedals, the cycle moves a certain distance. After that, the cycle stops. Now, why the cycle stops, this one I will say you later on. First of all, why the cycle is moving? The cycle is moving due to this property of inertia of motion. What does it mean? When you are riding the cycle was in a state of motion. When you have stopped applying a force on the pedals, the cycle, due to its inertia of motion, tries to remain in its state of motion. So, the cycle continues to move with the same velocity and in the same direction even in the absence of the force. So, this clearly suggests that inertia of motion is a property of this cycle also. Now, let us see with the help of another example. Suppose a person is standing on a bus and the bus is moving. Now, if the person suddenly jumps out of the moving bus, he falls forward on the road. Why does this happen? This happens again due to the property of inertia of motion. Let us elaborate this one. When the person was standing on the bus and the bus was moving, his entire body, his whole portion of the body was in a state of motion with the bus. Now, when this person suddenly jumps out of the bus, his feet comes in contact with the ground. Now, once his feet comes in contact with the ground, his body's lower portion immediately comes to rest. So, suppose this is the ground, this is the person. So, the person's lower part, since this is the ground is not moving, the ground is in a state of rest. So, when the person suddenly jumps out of a moving bus to the ground, what happens? His body's lower portion comes in contact with the ground and his body's lower portion immediately comes to rest. So, this portion immediately comes to rest. But his body's upper portion, due to this property of inertia of motion, tries to continue to remain in a state of motion. Why? Because the person was initially in the moving bus. So, this body's upper portion tries to remain in a state of motion. So, this part tries to remain in a state of motion. Now, these two happens simultaneously. His body's lower portion comes to rest and his body's upper portion remains in a state of motion. So, what is going to happen? He is going to fall forward. So, that means he is going to fall face down. Let us see with the help of one more example. Suppose, for example, you are standing on a bus. Now, this bus is a very common topic. The bus or train is a very common topic or it's a very easy topic for understanding inertia. So, suppose you are standing on a bus. This is also a very common sight. I hope all of you have seen this one or all of you have experienced this one. You are standing on a bus, moving bus. Right? So, this floor of the bus is moving. Now, when the bus suddenly stops, what happens? You fall forward. Now, why does this happen? When you are on the bus, that means on the moving bus, your entire body was in a state of motion. So, your entire body is in a state of motion. Now, when the bus suddenly stops, what happens? Your body's lower portion, since it is in contact with the floor of the bus, it comes to rest immediately. So, this portion comes to rest immediately. But your body's upper portion, due to this property of inertia of motion, tries to remain in a state of motion. So, your body's upper portion tries to remain in a state of motion. So, this two happens simultaneously. Your body's lower portion comes to rest, but your upper portion tries to remain in a state of motion. So what is going to happen? You are going to fall forward. Now one more important thing about inertia is, inertia depends upon the mass of the body. This is very important to understand. So inertia depends on the mass of the body. Now what does it mean? It means that more the mass of the body, more will be the property of inertia of a body. For example, suppose we have a small stone lying over here and we have a very large stone lying over here. Now you are applying a force over here to move the small stone and you are applying a force over here to move the large stone. Now if I ask you in which case you require a greater amount of force to bring the two stones to a state of motion, yes, of course the answer will be in the case of a second stone. Now why is this? This is due to the fact that inertia depends upon the mass of the body. Now the mass of this stone is obviously greater than the mass of this stone. So the property of inertia is more in the case of this stone than in the case of this small stone. That means the tendency of this stone, the larger stone, to remain in its state of rest is much more than the tendency of this small stone to remain in its state of rest. So to move both the stones, in case of the second one, you require a much larger force to bring the stone in a state of motion. So this is very important. Inertia, it depends upon the mass of the body. So more the mass of the body, more will be the property of inertia of the body. So this one also goes in the case of when a body is in a state of motion. Okay, so when the body is in a state of motion, so more the mass of the body, more will be the tendency of the body to remain in a state of motion. And if you want to stop the body, in the case of the body which is of a larger mass, you require a larger amount of force to stop the body. Now I hope all of you have understood the law of inertia. Now let's go back to Newton's first law. Newton's first law stated that any body which is in a state of motion will remain in a state of motion unless they are acted upon by an external and unbalanced force. And any body which is in a state of rest, it will remain in a state of rest unless they are acted upon by an external and unbalanced force. So you can understand that Newton's first law is actually the law of inertia which was stated by Galileo. Now what Newton did? This law of inertia was taken as an insight by Newton and he resurrected it and compiled it and he stated it as the Newton's first law of motion. So according to Newton, a body which is in a state of motion will remain in a state of motion and a body which is at rest will remain in a state of rest. So to understand Newton's first law and the law of inertia, both are more or less the same. What Newton did, he compiled the laws together, okay, and he stated them as Newton's first law. Now one more very important thing we get from Newton's first law of motion is the definition of force. He said the body will remain in a state of rest or state of motion unless they are acted upon by a force. So we can get the definition of force from this Newton's first law. So what is actually force? So force is an external cause which tends to change the state of rest or the state of motion of a body. So force is an external cause which tends or it tries to change the state of rest or the state of motion of a body. That means, suppose a body which is in a state of rest. This body is in a state of rest. Now if you apply a force, this body can go in a state of motion. So what is force? So this is force. So this force is actually trying to bring the body to a state of motion. And suppose a body which was initially in a state of motion. So this body, suppose it was moving. Now if you want to stop the body, you have to apply a force from the opposite direction. So this is the force. So if the force is strong enough or if the force is large enough, this force can actually bring the body to a state of rest. That means the velocity of the body is going to be 0. So force is the external cause which tries to change the state of rest or it tries to change the state of motion. So this definition of force was also described by Newton in his first law of motion. So one more important thing was also present in Newton's first law. He said the body which is in a state of rest will remain in a state of rest unless they are acted upon by an external and unbalanced force. The same goes with when a body is in a state of motion. Now what is this unbalanced force? Let us understand balanced force and unbalanced forces. Suppose, for example, this is a body lying over here. And if I apply a force over here that is equal to, for example, any force, suppose the magnitude is 10 Newton. So this body was in a state of rest, and if I apply a force, suppose the body is going into a state of motion. So in this case, you can state that this force is an unbalanced force. So in the presence of an unbalanced force, the body will go in a state of motion. What is a balanced force? Suppose, for example, I am applying a force on this side which is equal to 10 Newton. At the same time, I am applying a force on the opposite side which is also equal to 10 Newton. Now let's see what is going to happen. I am applying a force, that is correct. But in this case, from both the sides I am applying the same force. So you can understand these two forces will ultimately cancel out each other and the body will continue to remain in its state of rest. So you can understand in this case, these two forces are balanced forces. So in the presence of balanced forces, the body will continue to remain in its state of rest. Only in the presence of an unbalanced force, the body will be displaced. That means the body which is at rest will be in a state of motion. Now this is also applicable for the body which is moving. Now when your body is moving, if you apply an unbalanced force, you can actually stop the body. The body will ultimately come to a stop. But if you apply balanced forces, the body may not stop. The body will continue to remain in its state of motion. Now one last thing that I told you I will explain later on is that suppose you are riding a cycle and you stop paddling, the cycle continues to be in its state of motion. Now according to the law of inertia, the cycle should continue moving forever. But that does not happen. After moving a certain distance, the cycle stops. Suppose you have a ball and you roll down the ball on the floor. Now according to the law of inertia, the ball should continue to remain in its state of motion and it should continue to move forever. But that also does not happen. After moving a certain distance, the ball eventually stops. So this, you are thinking that this is actually violating Newton's first law. But this is actually not violating Newton's first law. Why the cycle or the ball is stopping? There can be many forces which are responsible for this one. The primary force which is responsible for this one is the force of friction. Now when the ball is moving on the floor or the cycle is moving, the force of friction is acting on the cycle or the force of friction is acting on the ball. And this force of friction acts on the opposite direction of the motion of the ball. So this is the motion of the ball, okay, and this is the force of friction. So this friction is acting in opposite direction to the motion of the ball, and eventually this force of friction is bringing the ball to a state of rest. So Newton's first law is not being violated over here. Now in the absence, if there are no friction, so in the absence of friction or any other resistive forces, the ball will continue to remain in its state of motion forever. So that was all about Newton's first law of motion. I hope all of you have understood the topic clearly. If you like the video, please give a like and make sure you subscribe my channel. Now if you have any other questions or if you want me to discuss any other topic, make sure you comment down below. I will try my level best to answer your questions or to make a video upon the topic suggested by you. So goodbye, take care, have a good day. And before signing off, check out this interesting fact.
It is said that Newton loved animals, and one of his best friends was his dog, a Pomeranian named Diamond. According to historical research by a highly respected professor, Stanley Coren, in his book The Paw Prints of History, a story goes that one day when Newton was working, he heard a knock on his front door. Newton got up from his desk and closed the door to his study to see who was knocking at his front door, leaving Diamond alone in the room where she laid next to the desk. The dog became excited when she heard an unfamiliar voice, began running around the room and bumped into the desk, knocking over a lit candle that set fire to the manuscript Newton was working on for 20 years. Despite the loss of much work and getting angry, the scientist lifted his beloved dog to his arms and said, "O Diamond, Diamond, thou little knowest the damage thou hast done." Such was the greatness of this man.